Hi everybody, sumchief here. Today we're going to be looking at binomial coefficients and how to calculate it and how to expand the calculations for this thing here, a plus b to the power of 6. Now that is quite a lot of foiling to complete. So basically that means a plus b, 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 a plus b 6 times all multiplied out. As you can see, that's going to take a long time. So there's a nice little shortcut to try and work this out. It's called the binomial coefficient expansion. So the first thing you see is this here, which is like brackets. It's like a matrix, n and k. So n is the number of times you want to expand it, then k is which degree you're on. So the n in this case would be 6, and then k is for the first term, second term, third term, fourth term, fifth term, sixth term. Each will be calculated individually. So on a calculator, it's seen as NCR, which is N choose R. So you'll find that on most calculators that are scientific ones. So have a look for that. And then here we come to the formula. N choose K equals N factorial divided by K factorial times N minus K factorial. So basically N factorial, that will be always the number of terms you're trying to achieve. So that will always be, in our case, 6. So that's 6 factorial. Then K factorial, that's the one we're on. So first, second and third, that'll be 1, 2, 3 factorial. And then N minus K, so you multiply that by, so if you're on the third one, you do 6 minus 3, which then be 3 factorial. So it'd be 3 factorial, 3 factorial. So I'm going to go to that a little bit more detail now. So here we've got an example, 6 degrees of expansion, which will always yield 7 coefficients to find. And that's because you're going from 0 to 6. So here's the formula here. So n choose k. So each time n is 6, k is going from 1, 0, 1, 2, 3, all the way up to 6. So 6 choose 0. Well, 0 factorial, that's always taken to be 1. So don't worry about the 0 factorial. So 0 times 0 is 0, but it's taken that 0 factorial is always 1. So 6 factorial is 1 times 2 times 3 times 4 times 5 times 6. Then on the bottom you've got 0 factorial, which is your 1, and then your 6 factorial, which is 1, 2, 3, 4, 5, 6, all multiplied together. Now what you'll see is that a lot of cancelling out here. 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6 will cancel out, which then leave you with 1 times 1, which is 1. So your first coefficient will be 1. Then on to the second one, you got n choose 6, k equals 1. So there we go, 6 and 1 in there. 6 factorial times 1 factorial times 5 factorial. So as you see here, k is 1, that's the one we're working out. 6 minus 1 is 5. So now we've got the 6 factorial, as always, on the top. 1 times 2 times 3 times 4 times 5 times 6. And then we've got 1 for 1 factorial, and then 5 factorial, which is 1 times 2 times 3 times 4 times 5. Now this time you'll see the 1s will cancel out with the 2s, 3s, 4s and 5s, which will leave the 6 and the 1. So then we've got 6 divided by 1, which will give us 6. Similar thing moving on, 6 to 2, so 6, n choose 6, that's 6 choose 2. That's 6 factorial, 2 factorial times 4 factorial. So here we go, 6 factorial on the top, 1 times 2, that's 2 factorial, and then 1 times 2 times 3 times 4, which is 4 factorial. And then with the relevant crossing out, you have 5 times 6 divided by 2 times 1, which will give you 15. So you get the idea. So now we're on to 6 choose 3, which is the same, 1 times 2 times 3, 1 times 2 times 3. With all the cancelling out, we have 5 times 6 times 4 divided by 2 times 3, which is 120 divided by 6, which give you 20. And then the same here, 6 factorial, 4 factorial, 2 factorial, and again all the cancelling out would lead you to 5 times 6 divided by 2, which is 15. 6 choose 5, which will lead you to 6, and 6 choose 6 will lead you to 1. Now what you'll notice is here that 6 choose 6 is the same as 6 choose 0. 6 choose 5 is the same as 6 choose 1. 6 choose 2 is the same as 6 choose 4. So by the time you get past halfway, they will all you will have already worked out which ones they are. So if you work them out in that way, so the first and the last will always be the same. Okay, so now we've got a plus b to the power of 6. So we're going to use our coefficients. So 1, 6, 15, 20, 15, 6 and 1. So now we're going to put these in. So we've got, so starting off with a to the 6, b to the 0, a to the 5, b to the 1, a to the 4, b to the 2, a to 3, b to 3, a to 2, b to 4, a to 1, b to the 5, a to 0, b to 6. So a simple way of writing that is just your a's will start from 6 and work down, your b's will start from 0 and work up, and then your coefficients you just slide in front of it, your 1, your 6, your 15, your 20, your 15, your 6 and your 1. So that's how you'll work that out. And as you know, b to the power of 0, anything to the power of 0 is 1, so that will just cancel out. And also the 1 times a to the 6 is just a to the 6. Same at the other end, a to the 0 is just 1, so just leave you with b to the 6. So which simplifies to this, a to the 6 plus 6 times a to the 5b plus 15 a to the 4b2 plus 20 a to the 3b3 plus 15 a to the 2b4 plus 6a to the b5 and plus 6 b to the 6. Okay, so that's how we work that out. And now I'm going to show you now is something called Pascal's Triangle, which is quite an interesting thing to look at. So here it is, all the way up to 17. So that's what it looks like. So to explain to you how this is made, if you look closely, the two values which straddle the box above, they make the box below. So basically, if you look here, 6 and 15, 6 plus 15 is 21. Here we got 3 plus 3 is 6, which makes 6. So same down here, 15 plus 105 is 120. And you'll find that for all the triangles positions. So 1365 plus 3003 gives 4368. So you start off your triangle 1, 1 and 1, and then now you've got your 1, 1 and 2. So this 2 here is made from this 1 and the 1. And then this one here, you've got 1, 1 and 3, because 1 plus 2 gives you 3. It's the same again, 1 and 3, that give you 4. 3 and 3 give you 6. 3 and 1 give you 4. 1 and 5 give you 6. 5 and 10 give you 15. 10 and 10 give you 20. So this is our expansion we just worked out. 1, 6, 15, 20, 15, 6 and 1. And if you have a look, that's what we calculated. So that's how you can calculate at any space in the Pascal's triangle. So that's interesting to see. So there's an example there all the way up to 17. So here you got some really big numbers down in the middle there, 24,310. As you can see, the pattern, when you get to the 24,310 at the bottom, it then starts to go outwards and repeat. So 19,448 each side, 12,376 each side, 6,188 each side, and so on and so on. And it can be the same for every single one. So here you've got 70, 56 and 56, 28 and 28, 8 and 8, and 1 and 1. So that's the same for all of them. So good to have a look at that one. And then here's another way of using Pascal's triangle to work out your binomial expansion. So using the Pascal's triangle, for example, a plus b to the power of 1, well that's just a plus b, isn't it? So that's 1 and 1. So that's taken from the triangle 1 and 1. A plus b squared, as you see you've got 1, 2 and 1. So you've got 1, 2 and 1 here. So a plus b squared is a squared plus 2ab plus b squared. Same again, a plus b cubed is a cubed plus a squared b plus 3ab squared plus b cubed. You see again and again and again. So 14641, 14641, and again a to the 4, a to the 3, b to the 1, a to the 2, b to the 2, a to the 1, b to the 3, and b to the 4. Same as the system we just worked out. Same again with a to the 5, a plus b to the 5, so 1, 5, 10, 10, 5, 1, 1, 5, 10, 10, 5, 1. And the same system, a to the 5, that's b to the 0, which is cancelled, a to the 4, b to the 1, a to the 3, b to the 2, a to the 2, b to the 3, and a to the 4, and b to the 5. And if you notice, all these indices for a and b will always add up to 5. So if you a plus b to the power of 5, you're always adding up to 5 here, because you've got the 1 there which is not written. So a to the 4, b to the 1, and they all add up. So if you know you've got 5 in the indices, you know you're on the right track when calculating. Let's go back to the original one we did, and you'll see there, look, we got 6, so we got 5 and 1, 4 and 2, A and is 3 and B and 3, A2, B4, A and B5, and B6. Okay, so that's how we do binomial expansion. Okay, so thanks for watching. Any comments leave below, and please always remember to subscribe. Thanks very much.